Go math. Yeah, so you'll need a little notebook just to make notes on there. Oh, no problem. No, it is certainly not, Sam. Yeah, it's important to go through and really know those integers. That's why we kind of, no, that's not bad. That's never bad. Never, ever, ever bad. The lessons here are kind of quick. They are going to get a little more intense. We're going to get into equation solving. We're going to get into graphing. So it's okay. It's fine. I am going to put restrictions on the weeks because I don't want you guys, when you're in a group-paced class, you're really not supposed to work super far ahead. Otherwise, it defeats the purpose. But for now, it's totally fine if you work ahead. It's okay. And Junior, you are joining us now. You will not have to go back and do every assignment. I just want to clarify that. If you look at our Moodle page, Junior, I'll show you. Are you there, Junior, or are you still on break? I should have checked that, right? Okay, great. So this is our Moodle page. And right up here, I have what's due for the week. But we're in week 5. So you have 4 weeks ahead of you that you were not here, but you do not have to go and do all of that. Okay? I'm going to get rid of the live lesson requirements for you, so you won't have to do that. And I'm just going to have you do maybe a lesson on multiplying, dividing, adding, and subtracting. Boom, that's it. So I'll have you do a few things just to see where you're at with integers. Might just have you do the integers pretest and the introductions, but I will adjust that today, Junior. So by the end of today, if you're looking at it and you're like, wait, why is it showing this? You can just email me and I will get back to you right away. Right away. Hold on one second. I'm making a note. Juniors, snapshots. And if you do work ahead, and let's say you didn't get 100%, remember you can go back and fix that. That's why Math Excel is awesome. So yeah. Oh, Junior, I got to get you added to Math Excel. I will do that too. Okay, Math Excel. Okay, so right now you guys should have a notebook. If you've already completed your math, it's still a good idea to have it just in case you missed something. Not a big deal. And yeah, we'll go through our notes here real quick. All right, this is what is due this week. Ah, stop that. Okay, this is what is due this week. We've got today's live lesson. You've got a multiplying and dividing assignment in, hold on one second. I gotta move my annotating thingy here. You've got a multiplying and dividing assignment in that quiz. And then all of the integers in that quiz. So Junior, you know what I might do? I think I'm just gonna have you focus on this week. And we'll just kind of forget about the last week. I don't know. Maybe it's shady. But the main thing our lesson about is exponents and prime and composite numbers. Okay? That's our main thing there. And what am I looking for in a live session from you guys? Can you guys help Junior out? What do you guys think? What do I want during a live session? What are my students' expectations? Our attention, yes.
Not to be distracted.
Present. Try not to be distracted. Yeah, and I get it. You know, I distract myself half the time when I'm talking, so I get that. But right. Talk or type to answer questions. It just goes quicker. Thank you. Very good. You guys are awesome. All right, just a little a neat little visual of our integer rules. So if you're looking for a way to kind of get those integer rules all in one visual, here you go, right? It's pretty awesome. When you're adding integers, if both numbers are positive, your answer is positive. If both numbers are negative, your answer is negative. If your bigger number is positive, your answer is going to be positive. If your bigger number is negative, your answer is going to be negative. And remember, when you have two different signs, you're really subtracting. And then for subtraction, you want to change the subtraction sign to an addition sign. So if we're going like 3 minus 4, that is exactly the same as what addition problem? What do you guys think? What is 3 minus 4 exactly the same as? No, that's the tricky part. Remember, this sign does turn positive, but then where does that negative go? Doesn't go on the 3, that's too far. You can see my hands. Ooh, my camera. I wish my camera was higher. There you go. Oh, gotcha, gotcha. So what would this turn into? 3 minus 4 turns into 3 plus negative 4. Yeah, very good. Very good, very good. And then when you multiply and divide, if both of the signs are positive or negative, your answer is positive. But if you have one negative in the multiplication or division problem, your answer is going to be negative. So yeah, and this is a Google image. So if you ever forget your integer rules, you can just type in integer rules and click on Google Images. It's perfect. So many cool images up there. I'm forcing my mom to watch Frozen. She's getting into it. All right. Oh, that's a great idea. Yeah. It's a good visual. Is anybody else writing this down and I need to leave it? Because I'm happy to do so. Can snip it. All right, all right. Oh, that's a good idea. But remember, oh. I gotta show you guys. Do you want to see my beautiful little niece? That's my little niece. She hung out with me this weekend. So cute. Such a cutie. I thought her shirt said little butthead. That's what I thought it said. I was like, what? But it actually says little but fierce. That's what it says. Yeah, see, because she had her blanket, and for the longest time, it just looks like it says little butthead. I was like, oh, what? But no, it says little but fierce. That's my little girl. Here, I got a cute picture of her with my daughter. This is my daughter's the sassafras one. Right? I don't know how I went there. Maybe it's because my sister always called her older daughter a little butthead. Affectionate name, you know. Maybe not, I don't know. My sister's a weirdo. Okay, you guys got this written down? Junior, how do you feel about integers? Uh-oh. He's going to get you. Slice. Okay. Yeah, and if you're looking at it and you're like, wait, what? This is crazy. Remember, you can always, shoot me an email, whatever. I'm not going to have you practice over and over with integers. So I will fix that list today. So don't worry about it. So very cool. All right. Well, we are going to talk about exponents. And it's really good, really brief notes. So nothing super heavy. Okay. The important thing about exponents, what everybody gets confused about, is what this all means. Okay. Right here, what this means. They get really confused. Oh, Junior, and to bring that up, if you take your cursor and bring it to the top of the screen, there's a little arrow that says View Options. You click on it, and then you can go to Annotate, and it lets you write on the screen. But kind of rules of the road here is while I'm explaining, I just want you guys to look at it. You're welcome to check it out now. You wouldn't see as much cameras. What do you mean as much cameras? Like cameras on?
There aren't many cameras on right now.
Much camera? Yeah, that's true. Do you mean cameras on? Is that what you mean? Yeah. Yeah, people are doing really good about there's not a lot on right now, but you're right. Hi, May. Hi, May. Yeah, I love how you guys turn your webcams on because it feels like we're talking to people then. I love that. That's a good point. And I'm glad you said that, Sam, because it's saying that people are turning it on more. And it's okay to turn it on. It's okay to not turn it on. It's all good.
Our first science live session, pretty much everyone used their webcams.
That's cool. Well, your teacher is Leah, so Leah's just amazing. I get it. That's so cool. Yeah, you got to be in the mood too. And I figured out how. I have no idea how I did it, but when I don't have my webcam on, check it out. I got a unicorn picture. Don't know how I did that, but yeah, it's there. So pretty cool. Okay, so anyway, back to exponents. What thing? Yeah, yeah, it's pretty good. It's awesome. I love it. You'll get there. We'll get you there. Oh, hold on one second, my friends. 1 second. Guys, I just want you to know I approve of this conversation. Culver's is amazing. Love Culver's. So sorry about that. I'm usually not as distracted, but my kids are home. That's okay. We're doing good. We're doing great. So it's good. Okay. Oh, there's no Culver's on there now. Yeah. I'm just kidding. Okay. So exponents, when you have something written as an exponent, okay? Yes, Aiden, you're so right. Right on the money, my friend. When you have something as an exponent, so this example is 3 to the 5th. This number here tells you how many times you multiply this number. So if you see 3 to the 5th, that means you're multiplying the 3 5 times. Most commonly, people will just go 3 times 5. And you got to be careful not to do that in May. That's perfect. You're right. And just remember, 3 is the base, 5 is the exponent. So that is the main thing to remember. Don't just multiply. Oh, sure, of course. Thank you for telling me that. This tells you how many times to multiply this. Okay? 6 times 6. What would that? Oh, yeah. And then, like, how to evaluate it, Sam? Is that what you're saying? Yeah, because that's a really good question. How are you going to sit there and multiply it? And just remember, when you see a bunch of stuff written like this, it's common to think, oh, 3 and 3 is 6. But remember, that's adding and stuff. So what I do is if it's 3 times 3 times 3 times 3 times 3, I will multiply the first two and then bring down the rest. Then I'll multiply the second two. And this is where Jen stops multiplying things in her head. I can't change you right now. I'm busy right now, okay? Yeah, but are you okay to move? Yeah. Okay. Only if you're okay. Okay. Questions on that, guys? Okay. Pretty cool.
Okay, so it's not like the answer wouldn't be the same as 3 times 5. It's usually like 15, right? So it's not 15?
It's not 15, yeah. And most commonly, that's what people do, is they'll say it's 15, but you're going to get a really high number because you're taking 3 and you're multiplying it by itself 5 different times.
Mm-hmm.
And you can do it in any order. Sometimes people will go, oh, this is 9 and this is 9. So this is actually the same as 9 times 9 times 3. Oh, yeah. 243. Yeah. And Sam, are you just showing a different way that you thought of it? Good question. This is a very common thing in algebra. You'll see it with a lot of order of operations. Exponential growth and exponents are very helpful because, right, yeah, and Sam, a lot of people do that. But anything with exponents and graphing exponents, like if we were to graph, when later on we're going to make graphs of like y equals maybe 3 to the x as an exponent. Graphs like that show things that go up really, really quickly. So maybe modeling like the population of a city or if you have if you're a scientist and you're culturing bacteria to come up with a virus or an infection or an antibiotic or something, they'll use exponents to figure out how much of one material they'll need to put in to get the end result. It's really interesting. Great question, Isaiah. But for now, we just want to focus on what it means. Okay? So for example, we're going to practice putting stuff in notation. So here I have 7 that is being multiplied 3 times. Can someone write on the screen, what do they think that would be as an exponent? And remember our example before, 3 to the 5th means multiply 3 5 times. Yes, 7 and tiny 3. Isaiah, I love how you wrote that. And person who wrote on the screen, great job. 7 is the number that you're multiplying, and 3 is how many times it's being multiplied. Very good. What about 3 times 3? What about that one? So close, Isaiah. I'm going to agree with the 3. Yeah. Very good. And Isaiah, were you probably thinking, yes. Isaiah, were you probably thinking there's a 3 there, you only worry about the other 3? That's what I would think. You don't have to count the first one because it's already the base. That's what I do. I totally get that. Yeah, so in this case, you don't have to worry about this 3 being counted as a base. You just, that's the base, and count how many times it's there. That's it. Good. What about number 3? And Junior, you are right, Sam, 7 and a tiny 3, and the answer is 343. Yeah, you're evaluating. 49 times 7, because 7 times 7 is 49. And I have no idea what 49 times 7 is. Let's see, 49 times 7. 343, you got it, Sam. Very good. I like what I see for number 3. There's only 6's there, so 6 is the base. And there are 1, 2, 3, 4, 5 6's. So 5 is your exponent. Good. Now what would we do for number 4 to write that in exponential notation? And remember, they don't want you to evaluate. If they just want exponential notation, they just want what it is. Very good, Sam. What about number 4? What would we do there? 3 and a tiny 4, 9 and a tiny 3. You're right. Yeah, you can only put what has the same base together in that exponent. So there are 4 3's. Yep, and my person writing it over there, I love it. And then there are 3 9's. And then we would just keep that multiplication sign in between. And I just want to bring up, we really don't use an asterisk for multiplication. It's usually supposed to be a dot, but on my computer, I just didn't feel like. 3 tiny 4 times 9 tiny 3. You're right. Very good. Very, very good. That's right. Any questions on that?
So the difference between this and multiplying would be multiplying is the number added that many times, and this is the number multiplied that many times.
Great. You are so right. Yes, that is so true. If we wanted to represent numbers that were multiplying, like if we want to go 3 times 2, that means that we are adding one of those numbers that many times. You're either adding 3 twice or you're adding 2 3 times. You're right. Very good. This one's a little different. Yeah, very good. And did you get a number right here? Did this person get a number like, oh, that's times. Okay, that's a comma. Yeah. 59,000. Yep, good. And guys, is it okay to use a calculator when you're multiplying these bigger numbers? Do you think I'm okay with that? Say yes, because I totally am. Yes, I am. It's totally fine. It's okay. I want you to know how to do it. So what I did up here, how I multiplied the numbers I knew, and then multiply by 7. Yeah, it's always good to do. Always good to try it in your head and then check it. That's right. Very good. You guys are amazing. Amazing. Okay. So now we're talking about evaluating expressions. Kitties are good like that. So what I would like you guys to do for evaluating expressions, I just want you to write what it means. And then you can use a calculator. That's fine. So 9 to the second power. And whenever you see this little caret, this is called a caret. That's another way of saying 9 squared. So what does 9 squared mean? What am I multiplying? It's called a caret. Yeah, I know. It's really weird. 9 times 9. Yeah, 9 squared means I'm multiplying the base 2 times. So 9 times 9. And what is 9 times 9? 81. Very good. You guys are awesome. Very good. And it does say the word evaluate, so they do want the answer. Yep, 81. Yeah, and it's not a power, it's just the answer. Right. Very good. All right, so what about number 2? What does 6 raised to the first power mean? What about that one? It's just 6. Yeah, it's like saying you're going to multiply 6 one time, but that's just 6. Anything to the first power is just the base. Good. What about 3 to the fourth power? Yep, you're multiplying 3 4 times. Very good. Right. Also 9 times 9. Let's see what we get when we come up with it. So we're going to go 3 times 3, definitely 9. And then you can either do what Vivi did and say, this is another 3 times 3. Sam, you're getting ahead of me there. He's just too on. Yeah, no, I'm just kidding. You're right. Very good. We'll get to that in just a minute. So you can either go 9 times 9, which is also that 81, or you can go 9 times 3, which is 27, or 9. Yep, and it's the same as 9 squared. Very good. And then Sam kind of already attacked this one, which is totally awesome. We just have 1 5 there, and then we have 2 6s. And guys, for this one, is it okay to multiply these first? Bullying my mouse. Oh. Is it okay to multiply the 5 and the 6 first, and then whatever you get times that 6? Can I do that? Do I have to go 36 times 5? If you're thinking, I probably can go 5 times 6 first, you're right, I can. And I would do that, because what is 5 times 6? Not 20, a little higher. 10 higher. 30, yeah, good job. 30 times 6. That's okay. And does anybody know the trick whenever you're multiplying 30, a number that ends in a 0, times 6? What's the trick that you can do to get that answer really quickly? 180, Junior, you're awesome. Very good. How did you do that? And some of you might be like, it's really easy just to punch it into a calculator. You're not wrong. It's the same as 3 times 6. Yes. And then you add that 0 back in. Very good. So it is 18. Add that 0 back in. Good job, guys. Nice work. Super smart. Super smart. Okay, we're going to talk about prime and composite numbers. So, what are prime numbers? I know it's on the screen, but I don't want to read it to you guys because you can read it. It's all good. But what are prime numbers? What do you guys think? Oh, well then let's go through it. See, it's good. Good guess. Most people think of them as odd numbers. Most people do. But it's not the case. It's okay if you don't use it, you know, who cares, right? But we're going to use it in math here. So a prime number is a natural number. So a number from like, not including 1. 1 is neither prime nor composite. We just kind of don't really count number 1. But they're not positive numbers. They are numbers who only can be divided or multiplied by 1 and itself. So these are some of the prime numbers. 2, 3, 5, 7, 11. They have factors or numbers that you multiply to get that number that are only 1 in itself. So they can't really be divided by anything. So see the number 29 here? You can't really divide that by anything except 1. So we call it a prime number. A composite number, yes. Yeah, you can have negative prime numbers. Good question. Good question. They only deal with natural numbers. That's just what we use to explain it, but they can be positive or negative. Yep. Composite number are natural numbers greater than 1 that are not prime. Oh yeah, there's a lot of, yes, you're right, Taylor. Composite numbers can have many things that you can divide it by. So this would be like 4, 6, 8, 9, 10, all that stuff. Can divide by a lot of stuff. So what we're going to do with this today is we're going to write the prime factorization. So we're just going to write a bunch of factors, like what they divide by. We're going to make a little tree. It's pretty cool. And it's called prime factorization because you get it down to only the prime numbers. So, yeah, good questions. Good stuff, guys. Okay, so we're going to write the prime factorization of 45. So what we do is we start with 45 at the top. And then we ask ourselves, what can be multiplied by what to give you 45? Let's split 45 into 2 factors. What can you multiply to get 45? And if you don't know, I would grab a calculator and just start dividing. I would go 45 divided by 2. Oh, that's a decimal. That doesn't work. 45 divided by 3. Ooh, that works, but someone here already wrote it. They wrote 9 times 5, which is perfection. That's right. 9 and 5. You could also have started with 15 and 3. You could have done 1 and 45. You could, but we want to avoid that because then it's like you're just dividing 45 up again. But you're right. You're not wrong. Now, which one of these can we split even further? The 9 or the 5? Which one can be divided again? 9. You're right. What times, oh, person, I forgot. I'm sorry. I didn't mean to write over your beautiful 3. That was good. Yeah, can you move it down there? Perfect. Yeah, 3 times 3. Very good. Can we split the 3s or the 5 even further? Can we split it up anymore? I love what this person is doing. Look what they're doing. They're not wrong. But do we want decimals? Yeah, and you would think it's no big deal because it's a 2.5. I love that you did that because that's what I think too. But they only want regular numbers, so that natural numbers. That means no decimals. So you're so right. And Junior, bringing this up about it's just because it's in the definition. When you talk about prime, it's a natural number only. And natural numbers are your regular counting numbers, like 1, 2, 3, 4, 5. So it's just in the definition. I know, that's what I would think too. I totally agree with you. But they want the prime factorization. So that means no decimals. So we can't go any further. So our final prime factorization of this one is 3 times 3 times 5, or what's another way I could wrote that? Yeah, that's a good point, Isaiah. It would just keep going. Yeah, you're right. So what's another way I could write 3 times 3 times 5 using exponents? Oh, pardon my yawn. I'm so sorry. Okay. What do you guys think? What's another way to write that? Same as what we were just doing. What's the matter? Okay. You'd think so. You'd think so. But what is being multiplied? Yeah. No, she's fine. 3 and a tiny 2. Spider's hiding. Oh no. She's just checking the fridge. Okay. So 3 and a tiny 2 times 5. Yes, and Sam's got spiders. Oh man. Go ahead, Liz. So 3 and a tiny 2 times 5. That's what we would kind of go with. And I'm thinking if you're saying 5 and a tiny 6, you're probably thinking some addition stuff in there.
Thanks, Mom.
You're welcome, baby girl. That's what I'm thinking. You're thinking there. But the reason it would be 3 and a tiny 2 times 5 is because there's 2 3s. So 3 is being multiplied 2 times, and then there's a 5 left over. That's it. And it would work out the same if you did it this way. What are my factors of 15? What times what gives me 15? Five times 3. You are right. Oh, you wrote it there. Look at that. I'm like looking at the chat. Sorry, guys. 5 times 3. So it's the same thing. There's 2 3s and then a 5. Perfect. Good job, you guys. Prime factors. Woohoo. Are there questions on that? Now we're going to do 80. Divide by 2. You are right. So 80 divided by 2. Oh, I see stuff here. 8 and 10. That's perfect. You could also do it by 2. Look at that. We're splitting it up. You could do 2 and 40 and keep going there. But I like the 8 and 10. Keep it going. What do you guys think? And don't forget, yeah, you need 2 arrows on the 8 and the 10. That's good. Oh, I messed someone's arrow up. I'm sorry. Yeah, so we're just splitting it up into the factors, 4 and 2. And then what are my factors of 10? Yeah, divide 20 by 2. You're right. So 2 and 40, and then 40 can split. Yeah, you can just divide by 2 every single time, Aiden. I like that. Aiden is suggesting dividing by 2 every time, and you can. That's right. So 2 and 10. Divide by 2 again. 5 and 2. That is a good way to do it. Nice. Junior, you suggested that as well. Very, very good. 2 and 1. Ooh, someone discovered the arrows. Very, very good. And then once we get it all down into 5s and 2s, that's as far as you can go. See, I get too into what I'm talking about and I don't go there. So good. So we can't go any further. And how many 2s are there in the factorization? How many 2s? In each one. Remember, each one's separate. So this one's 2 times 2 times 2 times 2 times 5. And this one's the same way. So that's our prime factorization. And then how many 2s are there? 4. There are 4 2s. Very good. And we're done. And they don't say to evaluate it. They say write the factorization so it's done. That's it. Any questions there? Any questions? If you have no questions, go ahead and say no questions. Because that would be lovely. That or just very good. Beautiful, you guys rock. All right, so last thing I want to share with you are our divisibility rules. Just so you know, if you're having trouble trying to figure out what it divides by, okay, if the last digit is 0, 2, 4, 6, or 8, it's divisible by 2. If the sum of the, so if you add the digits together, and you might get a number that's divisible by 3. And if the last digit is a 0 or a 5, it's divisible by 5. So just a little review there. But again, I would just take a calculator, get your big number there, so like 132, and then just start dividing by 2. Oh, 2 works. Yeah, they're pretty neat. Yeah, so like if you have a number here, let's take 147. I don't know. Oh, that's going to be prime. Never mind. Let's take 169. Yeah, we're almost done. This is the last slide. If we add those together, 9 plus 6 is 15. 15 plus 1 is 16. So you don't get a number divisible by 3 there. So, yeah. Yeah. But the last number is divisible by 3, so that would work. So some of these work, some of them don't. If I were you, again, I think the easiest thing is just to use a calculator and just keep going. Cat on the keyboard. Oh, snap. That kitty cat. Oh, someone's right. I interrupted someone's writing. I'm so sorry. What were you going to write on there? Ah, back. I'm going to go back. Yeah, you can kind of test it there. You're right. Long division skills, man. Very good. And Isaiah, you are free to go. We are done. So thank you for your attention. I apologize if it was a little crazy with my kiddos here. It won't be that way next week. But yeah, you are free to go. You guys did great work. If you need anything, my phone number is on there. You can text me or call me. Again, my email is on there. Let me know. Bye, kitty cats. Bye-bye. Of course you can, Aiden. I love Twitter memes. Memes are hilarious.